Hi to all, welcome to today's class of the triangles and its properties, class number 6. Today I am going to discuss right angled triangle and Pythagoras property. Pythagoras of Samos was a famous Greek mathematician and philosopher. He is known best for the proof of important Pythagorean theorem, which is about right angled triangles. Let me take a right angled triangle. Here, triangle ABC is a right angled triangle, right angled at B. Now, the side opposite to right angle, that is AC, we can call it as hypotenuse. And the other two sides, AB and BC, we can call it as legs of the right angled triangle. Now, let us see what Pythagoras property is. Here is a right angled triangle. Let me name the sides as A, B and C. Here, A is the length of the hypotenuse, B and C are the length of its legs. Now, let me make 8 identical copy of this right angled triangle. Here are the 8 identical copies of the right angled triangle with the sides A, B and C. Now let me take a square of length B plus C. Here is a square of side B plus C. Let me take one more square of the same size. Now you can say area of these two squares are equal. Now let me place 4 right angled triangle in the first square and the remaining 4 right angled triangle on the another square. Look at the first square. Here I placed 4 identical right triangles. Here also I placed 4 identical right triangles. We took the squares also identical, means equal area. Now what can you say about the uncovered area of the first square and the second square? Here in the first square, the uncovered area is a square of side A. Here you are getting 2 uncovered area in the shape of a square. Here the square is of side C and here the square of side B. You know, area of a square is equal to side into side. Let me take side of this square as A. Then area of the square you can write it as A into A. That we can write as A square. Now look at the previous figure. Here in the first figure, area of the uncovered part is a square of side A. Therefore its area we can write it as A square. Now in the second figure, area of the uncovered part. The uncovered part is of the form square of side C and side B. Therefore its area we can write it as B square, because side is B, B into B, B square, and C square. C into C, side into side. Now you know that these two areas, uncovered portions, are equal in area. So we can write this A square is equal to B square plus C square. That is, we can write A square is equal to B square plus C square. Then what is A, B and C according to that right angle to triangle? A is the length of the hypotenuse, B and C are the legs of the right angled triangle. So we can state Pythagoras property as square on the hypotenuse is equal to sum of the square on its legs. In a right angled triangle, the square on the hypotenuse is equal to sum of the squares on the legs. Let me check the result in another way. Here I have a right angled triangle. Let me keep squares on the legs. This side having 1, 2, 3, 4 units. So this is a 4 unit square and its area is 4 into 4, that is 16 units. You can count and find it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 square unit is the area, or this can be represented as 4 square. 4 square, 4 into 4, it is equal to 16. So here you have 16 square units. The other side is of length 3 units. So its square on 3 units is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. So this can be written as, that is, number of squares on one side is 16 and number of square units on the other side is equal to 9. Now let us see how many square units are there in the hypotenuse. Here you can find out 1, 2, 3, 4, 5. 5 into 5, that is 25 squares. Here 5 square, 5 into 5, 25 you are getting. Now you add 4 square plus 3 square, that is 16 plus 9, you are getting 25. That is, square on the hypotenuse is equal to sum of the squares on the other two legs or other two sides. Or in other words, we can say, if sum of the squares on other two sides is equal to square on the hypotenuse, you can say that triangle is a right angled triangle. If a triangle is given, sides are given, to check whether those sides are sides of a right angled triangle, you find out the squares and sum of two sides is equal to the square of the third side. Then you can say that triangle is a right angled triangle. Now let us go to the exercise questions. Find the unknown length x in the following figures. Look at the first figure. The sides are 3 and 4. Find the value of x. You can use Pythagoras property here. So we can write x square, you can write it as 3 square plus 4 square. That is, square on the hypotenuse is equal to sum of the square on the legs. Then is equal to 9 plus 16, that is equal to 25. Now x square means x into x. Now check what are the numbers multiplied by itself to get 25. That is, 5 into 5 is 25. So you can write value of x is equal to 5. Similarly, you can do the question number 2 and 3. Look at exercise 6.5. PQR is a triangle right angle at P. If PQ is equal to 10 centimeter, PR is equal to 24 centimeter, find QR. Now, first let us draw a figure. Here is the triangle PQR right angle at P. It is given PQ is equal to 10, PR is equal to 24. Now you can write PR square is equal to PQ square plus PR square, that is 10, sorry, QR square is equal to PQ square plus PR square, that is 10 square plus 24 square, that is 100 plus 576. 24 square means 24 into 24, that is 676. Now to get a QR, which number is multiplied by itself to get 676, you have to try. It is 26 centimeter. So you can write QR is equal to 26 centimeter. The same way you can do question number 2 and question number 3. For 3, figure is given, you find out A. Now, which of the following can be the side of a right angle triangle? How will you find out? 3 measurements are given, 2.5 centimeter, 6.5 centimeter and 6 centimeter. Which one will be the hypotenuse here? Look at the longest side, 6.5. So find out 6.5 square, 2.5 square, 6 square. Add any two of 2.5 square and 6 square. If you are getting the answer as 6.5 square, it is the side of a right angled triangle. Otherwise, it is not the side of a right angled triangle. That you can write as, first find out 6.5 square, that is 42.25, 2.5 square, that is 6.25, 6 square 36. Now add the length of the legs, 36 plus 6.25, that is 42.25. Now 6.5 hypotenuse square, we are getting 2.5 square. That is hypotenuse square, you are getting as sum of the squares of the legs, squares of the sides. Therefore, the given sides can be the sides of a right triangle. Remaining question, do in the same way. A tree is broken at a height of 5 meters from the ground and its top touches the ground at a distance of 12 meters from the base of the tree. Find the original height of the tree. That is the question number 5. Here let AC be the height. At a height of 5 meters, the tree is broken and it touches the ground. So you can write AC is the distance from base to the top of the tree, that is 12. AB is 5. Now by using Pythagoras theorem, find out BC. You can write BC square is equal to AC square plus AB square. After getting BC, to get the length AC, you have to add AB plus BC. Do try. Look at the question number 6. Angle Q and angle R of a triangle PQR are 25 and 65. Write which of the following is true. Now find out P. You can get by angle sum property, angle P is equal to 90 degree. Then hypotenuse will be side opposite to 90 degree, that is QR. So QR square will be equal to PQ square plus PR square. Do it. Now question number 7. Find the perimeter of a rectangle whose length is 40 cm and the diagonal is 41 cm. Draw the figure. Since ABCD is a rectangle, angle B will be 90 degree. So here you are getting right triangle to triangle ABC. Hypotenuse is given. So you can write AC square is equal to AB square plus BC square by Pythagoras theorem. Then find out the length BC. After getting length BC, that is the breadth of this rectangle, you can find the perimeter by the formula 2 into L plus B. Do try it. Look at the next question. The diagonal of a rhombus measures 16 centimeter and 30 centimeter. Find its perimeter. Perimeter means all the, here for a rhombus all the sides are equal. So if you find out one side, 4 into that side is the perimeter. Now to one more condition property is there for a rhombus, that is diagonal bisect each other at right angles. That means you will get A, or let O be the intersecting point of the diagonals. So AO, let AC be 16, then AO will be 8. Let BD be 30. So DO will be 15. So you will get a right angled triangle AOD. In right angled triangle AOD, you apply Pythagoras theorem, Pythagoras property, that is AD square is equal to AO square plus OD square. Then find out AD. After getting AD, 4 into side is its perimeter. So try to do it. Here are the answers for exercise 6.5. Do check it out. Now that's all for today's class. This chapter is finished. So have a nice day.